Today is the 19th. So before we can talk about logarithms, having taught this, I deleted my recording from second hour because I realized in hindsight I probably should have talked a little bit more about the rules of exponents before we talked about logarithms. So we'll come back to what a logarithm is after we go over some basics first. And then I think the rest of the lesson will just go smooth. Like you won't leave here with homework. It's a 40 question homework assignment worksheet. You'll be done once you get rolling. I'll be surprised if all 40 problems take you any longer than like 10 minutes. It's super easy. So no worries about that. So let's review some stuff about exponents, just some practice problems here. You can write these down or not. If any of them strike your fancy, like, oh, I should write that down. Otherwise, it doesn't matter to me. So let's just do some practice. What is 5 to the third? Good, 125. How about what is 8 squared? 64, right? How about 9 to the third? Nice. There were a lot of these. I think when we did our factoring unit, these were a little bit fresher in your mind. And since we didn't use big numbers like this for a while, but a lot of them have probably, for a lot of us, just kind of faded out of existence. But they're going to come back into play today. So the more familiar you are with things like 7 to the third and 6 to the fourth and 5 to the fourth and 2 to the eighth and just stuff like that, it's just going to be a more pleasant process for you. I wasn't so worried about these. The ones I was worried about were things like this. And this is something that we as a math department, I know we need to work on because where does this get hit? I've always been under the assumption that the rules of exponents should be taught in eighth grade math, which for you 11th graders means that you went through eighth grade math. For you ninth graders, since you skipped eighth grade math, uh, that's a problem for us. But we can knock out these rules in like 5 minutes. So whether you learned it or not, like the critical ones, here they come. Do you guys know what anything is when you raise it to the power of 0? It is 1. Yeah. And that, I mean, it is what it is. Like, even if it's a negative number, like if I took, say, like negative 40 and I raised it to the power of 0, I'm still going to get 1. So a power of 0 is pretty unexciting. It gives you 1 as a final answer. And I could explain why that is at some point if you're interested. But for now, just know that when you raise something to the power of 0, the answer is. Got it? Okay. The other one that I was concerned about coming into this lesson was this, because I'm not sure if this has come up for most of you before at all. First off, I'll just tell you, do not say negative 25. I mean, you can, but it's going to be wrong. You guys seen this before? What if I just told you that the answer was a fraction that looked like that? You think you could connect those dots, piece that together? If not, let me give you another one, because maybe you have like a little bit of a theory, then you kind of go, oh, you know how it is, like you get a theory or a conjecture, and then you see more examples that sort of solidify that for you. So how about this one? Or how about done? Yes. So I mean, again, that's the kind of thing that like I don't think it deserves a day like to teach that. That's our rule of exponents. It states that when you have something with a negative exponent, you simply reciprocate it and then apply the exponent as you normally would. So like this 5, for example, is currently a top 5. Like we would agree that he's currently a 5 over 1, right? Well, what happens is we reciprocate that to 1 over 5, and then we reapply the exponent as a positive version of itself. So Essentially, the whole number, like Gage said, just travels to the bottom, and then we assign the positive version of the exponent. Good. How about another one? Let's do like 2 to the negative fifth. What's that going to be? 1 over 32. Very good. I mean, we knew, like, even if maybe what you were struggling with was the 2 to the fifth, but I mean, we at least know this much that the 2 to the fifth traveled to the bottom, but the exponent changed to positive, and then 2 to the fifth, you just either you memorized it or not, but it's 32. So 1 over 32. That's primarily what I wanted to get out of the beginning of this was just because after the other class, I kind of thought, I don't know, it kind of felt a little awkward to teach those properties like right smack in the middle of the lesson. So I thought, let's just get that out of the way. So again, to summarize, anything with an exponent of 0 will equal 1, and anything with a negative exponent is just the flipped over version of itself and then evaluated. Good, good. Okay. Then let's talk about logarithms. Confusing at first. So a logarithm is really just an exponent. I always tread cautiously with this particular lesson because I remember for me personally how hard it was for me to comprehend the letters log. It took me a long time, and that could be attributed to the fact that I just wasn't ready. Maybe I wasn't paying attention. Maybe I don't know. But anything in my past that has caused me stress, I tend to pump the brakes a little bit when I talk to you guys about it. So as we go through this, at first the language is going to look a little bit weird, but I'm going to try to scaffold you up over the next few days to the point where the word log just doesn't bother you. Like becomes part of your normal vernacular. So I'm going to throw one up here and see if you can crack the code. So what we're doing today is called evaluating logarithms. So the part of it that's not going to be there is the 2. So this is called a logarithmic expression, and we're going to be simplifying or evaluating them. It's no different than like looking at 2 plus 3 and saying, oh, it's 5. Or if I put 10 squared, you go, oh, it's 100. Or if I said, hey, what's the square root of 25? Oh, it's 5. Here in a few minutes, you'll be able to look at things like this and just say, got it. So the answer that I had before I erased it was 2. Anyone want to make a conjecture, a theory as to why that odd statement on the board could be true? It is. It's going to be this thing that you're going to hear me refer to as the water cycle. And I don't know why I started calling it this a while back, but if you take this number and raise it to the power of this, you get this. And I just decided years ago, I was like, I don't know, I was probably in class one day. And I was like, oh, it looks like the water cycle thing from like earth science class. You know what I'm talking about? The water goes up and then goes in the clouds and comes back down. I don't know. It's just, it's just a name that I gave it. So yes, you nailed it. All three of these numbers that are connected by these arrows, they are players in the game. And so this number down here, I want you to know these words because I want to be able to communicate with you. I want you not to go, what'd you say? Like, I want you to know these words. The number down at the bottom of the logarithm, the little guy, is called, as you might guess, the base. The quote unquote answer on the right hand side is called the logarithm. So, like I said, a logarithm is really just an exponent. We're searching for exponents that make things true. And this one you would not guess in a million years. So I want you to get used to this. That red box is called the argument. All functions have arguments. So the logarithm is just a function, and the argument in this particular case is what we're trying to make, essentially. So you take the base of the logarithm, and then I give you the argument of the logarithmic expression, and you say, what exponent do I need on that base to turn it back into the argument? Pretty simple process, right? So let's practice again. Log base 4 of 4. It's one. If you have no idea what's going on right now, that's perfectly normal, okay? But all I'm asking you for there in code is what exponent would I have to put on that number that I just circled to make it equal that number with the arrow pointing at it. It's always just the hunt for an exponent. That's all a logarithm is a power. Because 4 to the first equals 4, then the logarithm equals. Okay, how about this one? Correct. The question there behind the scenes is 10 to what power equals 100? Yeah, a couple more warm-ups, and then we'll get to the ones that are just a little bit trickier. Tomorrow's going to get kind of nasty, just so you know ahead of time. So tomorrow we really put a lot of extra layers on the cake, and there's some weird things. So let's use today to just get masterfully fluent with this language here. How about log base 5 of 625? What's 5 to the first? So we know it's not 1, right? What's 5 squared? So we know it's not 2. What's 5 to the third? 125. What's 5 to the fourth? 625. Your calculator will do logarithms for you. It's not really the path I want us to go down today. Part of it is that your calculator will do logarithms with a base of 10, but it will not do logarithms. Not all calculators, some do different bases. So tomorrow we're going to start talking about common logs and natural logs. But for now, today, I really like you to kind of keep the calculator's involvement just to a kind of grinded out roll. Like in that case, you could have done like 5 to the third hit equals and gone, oh crap, 5 to the fourth equals, ooh, yeah. And then like, you know, your answer is 4. Like try to stay away from the LOG button until I kind of push us down that road. Okay, cool. So that's the warm up kind of side of it. Is everybody clear? The answer to the logarithm is the power or the exponent that's required to make the argument. Okay, how about correct? And this is where the beginning of the warm-up intro to today's lesson should show its usefulness now. You say to yourself, perhaps 10 minutes ago, I wouldn't have known the answer to this question because the question is 9 to what power equals 1? But now we know that to turn something like 9 into a 1, you have to use an exponent of 0. So the log in that case would be 0. Does that make sense? Yeah. Yeah, good. All you good, good. How about this one? Yes. So the issue here is I'm trying to turn a whole number base 4 into a fraction. So immediately my brain goes into I need a negative. Like I got to have a negative exponent on something to get it to flip down to the bottom. And so the question becomes like, how many fours does it take to make 16? Well, 2, 4 to the tooth, right? But because it's on the bottom, then my exponent or my logarithm is negative 2. Good. You guys got it? So like I said, it's really good to just have your calculator kind of in the ready position so you can just start experimenting. So do you guys all know what 3 to the second is? 9. What's 3 to the third? 27. What's 3 to the fourth? 81. And if you take that, 3 to the fifth, take your previous 3 to the fourth times another 3, you get 243. So again, what we learn by tinkering around with either the power tables that you had from when we did factoring cubes and stuff like that, or just from knowing how to experiment with your calculator, you figure out that I know this is going to involve the number 5 because I have to raise 3 to the 5th to make 243, but because it's on the bottom, it's just simply a negative 5. Okay, still good? Okay. Ah, lose my head. We're not attached. What's this one going to be? Nope. What's that? I agree with you. It couldn't be anything. Yeah, very good observation. Yeah. You cannot solve this or evaluate this or simplify this. In logarithms, you're going to find that there are certain rules that we have to follow. And this particular expression is undefined. And if you put that into a calculator, once you know how to do logs in a calculator, it will give you an error message. I don't know what kind of message, like a domain error, probably something like that. Because you understand, like, if you really get what logarithms are all about, you understand, like, really implicitly why this is undefined. The task at hand here is to say, okay, I'm going to take the number 7, and I want you to put some exponent on it. This is your mission, turned into 0. It can't happen. Like it literally can't happen. And sometimes people say, well, what about? And there's no what about. It cannot happen. If you raise 7 to the power of 0, you get 1. If you raise 7 to some big positive power, it gets really big. And if you raise 7 to some negative power, it just becomes a fraction. It cannot become 0. So one of the rules that you're going to add to your notes right about now is that the argument of a logarithm cannot equal 0. I remember from second hour, it was somewhat of a clumsy lesson, but I recall that I think we had 4, and I think then I pulled an Ahern and I came back like after the fact and said, oh, I forgot about this or this. So there wound up being 4 or 5 different rules that we had to put into our notebook. But the first one is this: you cannot have a 0 in the argument position, regardless of the base. Okay. How about this one? Again, I don't have a lot of money in my wallet. I bet I have like $6 right now, but I would give every one of those bucks to you if you could find me a number such that when you raise 5 to that power, the answer comes out as the argument negative 25. Again, you have to stop and think about what's within my power. Like, what could I do? I could make 5 have a negative exponent. That'll solve it. No, it won't. What we learned today is that a negative exponent doesn't make things become negative. It just makes them flip into fractions. So again, I'm literally powerless to turn a 5 into a negative 25 using exponents. Therefore, because there is no value for this, then once again, we say that this function is not this function, excuse me, this expression is undefined. The bottom line is this: to sort of summarize these two rules for you, to kind of put it in a nutshell, the argument must be a positive number. It didn't say like it can't be a decimal or a fraction, because as we've seen, having a fractional argument is perfectly fine. We just use negative logarithms to make fractions. So the bottom line is that your argument of your log cannot be 0, and it cannot be anything less than 0. There will be 7 problems on today's homework assignment that have undefined answers, and these are be 2 of the reasons why you'll get that. So argument of 0, undefined. Negative argument, undefined. Got it? And then finally, for this last couple of rules, I feel like there's a lot of rules that can kind of gel into one if we talk about it like this. But our other rule is that the base the base of your logarithm has to be a positive number, not equal to one. And you might wonder, well, why not equal to one? And maybe you're not wondering that, but if you are, let's take a look at why that is. Like, why is that a thing? Imagine I gave you this. Think about the silliness. Again, if you really are thinking about this and like you're not just daydreaming, you're thinking about logarithms, you understand that that's a silly thing for me to ask, right? Again, the question is fundamentally 1 to what power equals 14? It ain't happening, right? Take 1 to the millionth power, what do you get? You get 1. Take 1 to the negative 10th power, you get 1. Take 1 to the 0th power, you get 1. So, as a general rule, regardless of any situation, no one is ever going to ask you to evaluate logarithms with a base of 1. But if it happens to come up in the course of action, you could just say, no, not doing it. It's not defined. The logarithm function is not defined for a base that has a value of 1. Any other positive base can do. We might even see situations in which you have a logarithm that has a base where the base is itself a fraction. For the record, as long as it's a positive base to your logarithm, it is evaluatable. Anybody think of what log base 1/2 of 4 would have to equal? You're pretty good at this math stuff. I tell you what, you got the math thing. Yeah, it's -2 because if you take 1/2 and you raise it to the power of -2, remember what I said earlier, a negative exponent causes you to reciprocate the base. So the base becomes 2 over 1, and then you change the exponent to positive. So, Coop. So, anyways, base has to be a positive number, greater not equal to 1. It can be a fraction. It can be bigger than 1. It just can't equal 1. And of course, the base can't. I mean, lumped in with that yellow rule that I just wrote is this. Like, why is that not possible? Yeah. Again, if you understand the lesson, it ain't happening. You can't raise 0 to a power and go, hey, look, I got 41. It's just not going to happen. You could spend a million years trying and it's not going to happen. You're just spinning your wheels. And finally, logarithms cannot have negative bases. And I will come up with a better explanation. I feel like you deserve a better explanation than I'm capable of giving you here today. What I understand at this point is that it's just the law, and I'm not sure that I'm content just spewing that along here. But for now, just know that you cannot have a logarithm with a negative base. So, like if I asked you for log base -2 of 8, that also is undefined. So these last two expressions are undefined. Someone asked earlier, and I went on a long rant. You're not going to get a long rant. You're going to get a very short answer. The question was, would you actually take points off if I misspelled the word undefined? And the answer is, of course I would. Like, I respect you guys and hold you to a standard. I feel like if you can't spell a word like that, if it's in your notes or on top of your homework paper, then I think you and I are probably going to have some issues. So write it down at the top of your paper so that every time it comes up, you know how to spell it. So you don't want to be one of these guys. You know what I mean? Those are really bad. Those are bad. I'm gonna wake up one night in a pool of sweat and there's gonna be like this word with like hairy arms and legs just walking towards my bed. It's yeah, good. Yeah. Do you guys have any questions about just what a logarithm is? As they get more difficult tomorrow, you're going to see things like log base 7 of the fifth root of 49. And as long as we have today down pat and we understand the what am I really looking for thing, uh, I got you. What'd you say? No, the answer to this one would be 2/5. So That's tomorrow, okay? So today, just enjoy the ride. It's a nice, simple 40 question assignment. It's on paper. I'll hand it out. And like I said, I'll tell you, I didn't tell the other class. I don't know why I didn't tell them. There are seven that you will write undefined on. If you don't get seven, then you did something wrong.